Why modern apps don't talk directly to services. Imagine your shopping application has user service, product service, order service, payment service, and notification service. Now imagine your mobile app directly calling every one of these services. Sounds simple at first, but as the system grows, it quickly becomes difficult to manage, secure, and monitor. This is exactly why architects use an API gateway. Today we'll learn what an API gateway is, why it exists, and how it becomes the front door of modern applications. Let's look at a system without an API gateway. The mobile application needs to know the address of every service. The web application also needs to know where every service is located. If a service moves, changes, or gets replaced, all clients must be updated. As more services are added, complexity increases. Architects recognize this as a scalability and maintenance problem. An API gateway acts as a single entry point for all client requests. Instead of clients calling services directly, they send requests to the gateway. The gateway then routes those requests to the correct service. This creates a cleaner architecture because clients only need to know one endpoint. Everything else is handled behind the scenes. One of the primary responsibilities of an API gateway is routing. Imagine a customer searches for products. The request arrives at the gateway, which forwards it to product service. If the customer places an order, the gateway routes the request to order service. Clients don't need to know where services are running. The gateway handles all routing decisions automatically. Security is another major reason architects use API gateways. Before a request reaches any service, the gateway can verify the user's identity. It checks tokens, validates credentials, and ensures the request comes from an authenticated user. This prevents every service from implementing authentication logic independently and creates a centralized security layer. Authentication answers the question, "Who are you?" Authorization answers the question, "What are you allowed to do?" For example, an administrator may access management APIs while a customer cannot. The API gateway can enforce these rules before requests reach backend services. This improves security and simplifies application development. Imagine one user accidentally or intentionally sends thousands of requests every second. Without protection, backend services could become overloaded. API gateways provide rate limiting, which controls how many requests a user can make within a certain period. This protects applications from abuse, bots, and unexpected traffic spikes while keeping services available for legitimate users. Since every request passes through the API gateway, it becomes an excellent place for monitoring and logging. Architects can track response times, failures, traffic patterns, and user activity from one central location. Instead of collecting logs from every individual service, the gateway provides a unified view of system activity. Let's revisit our shopping application architecture. A customer opens the mobile app and searches for a product. The request reaches the API gateway. The gateway verifies authentication, checks permissions, applies rate limits, and routes the request to product service. When the customer places an order, the gateway routes that request to order service. Everything flows through a single controlled entry point. Let's summarize. API gateways provide routing, authentication, authorization, rate limiting, monitoring, and centralized management. They reduce complexity for client applications and improve security for backend systems. Great architects don't add API gateways because they're trendy. They add them because they simplify communication and make systems easier to manage at scale. In our next video, we'll learn how load balancers distribute traffic and keep applications available even when millions of users connect simultaneously.